Okay, hey, we've got example 5. We've got a graph here, and a whole bunch of points are labeled. And what it's asking us to do is to draw the tangent line at each of those points, and then estimate the derivative. What is the point? What's the behavior of the function at that point? And then the equation of the tangent line. So that's what we're wanting to do for each of those. Okay. So let's go ahead and do that. So on A, I'm going to go over here and I'm going to pick me a shape. We'll pick me a line. And I'm just going to kind of wing it at first, and then I'll make it a little bit better as we go. All right, so if I go here, I can pick it. There we are. Yeah. And then just kind of make it do a little bit better job. There we are. Grab a hold of it. So that's not terrible for a tangent line. Yeah. Okay. So there we go. So on that very first one, and I'd like to make it where you can see it a little bit better. There we are. So make it a little bit bigger and a little bit brighter. Good. Okay. So on that very first one, I don't know. I'm going to estimate the derivative. I've got some pretty clean points here, but man, this thing is very steep and a negative slope. So what we got? 1, 2, 3, 4, 5, maybe about -6. It does say to estimate. So that's what I'm going to do. So let's just estimate that to be about -6. Okay. And then the point of tangency, this was at -3. So -3, 1, 2, 3, -3. So the point of tangency is -3, -3. And behavior certainly is decreasing at that point. The function is decreasing. All right. And the rate at that moment, we are estimating to be -6. All right, so whatever the units may be. All right, so then as far as the equation of the tangent line at that particular point, I'm going to do point slope the way I like. I'm not going to do it this way. You can if you want to. You can switch it around if you want. But as far as I'm concerned, it's going to be y plus 3 equals -6 x, and then times x plus 3. And then we can move right along. Okay. All right. So then, we're moving to point B. All right. So point B is at -2. All right. So let's draw that. So I've got my shape. Let's have a line, and let's go straight across here. I'm gonna make that look better. So I'm gonna grab this. I'm going to attempt to grab this and make this better. Maybe it's that. Oh, there we go. Okay, so let's see if we can make that look a little bit better. Okay, there we go. All right, and maybe change the color a little bit, make it a little bit look. Okay, that should not be that difficult. And purple. All right, so there we go. Okay, and then if we wanted to, we could stretch it out a little bit, just so it looks a little bit better. Lord mercy. Okay, so all right, so there we go. And so at that point, the slope of that purple line, I believe, is 0. even though it doesn't look perfect, but it's pretty close. And that point is at -2, 1, 2, 3, 4, 5, -6. So I've got -2, -6. Okay, and the function of the behavior of the function at x equals -2 is a minimum. Now it's a relative minimum, but I'm going to put minimum anyway. All right, so we have a minimum there, and then our equation has a slope of 0. So there's no sense putting anything over here. So if we're doing it, it's going to be y plus 6 equals 0 times. All right, we're back. Equals 0 times x plus 2. But as you know, that is just a horizontal line, and so it's going to actually just be the equation y equals -6. Okay. All right. Move on to the next one. At this rate, this is going to take 500 years because of the lag, but we'll just keep on keeping on. So here we go. So now insert a line. It's going to be better than me drawing it, I'll tell you that much. And so let's go. Let's just try to make this look good as best we can. All right. Can't see that thing at all. So let's make it so we can see it. Good. All right. So make it a little bit bigger, make it a little bit brighter. And there we go. All right. And so, and I'm kind of happy with that. I think we'll just leave it right there. Might be able to move it a little bit. There we are. Okay. And so an estimate for that slope. Okay. So this is happening at -1/2. All right. So if I wanted to get a real feel for the slope, it looks like going from -1/2 to +1/2, I went up maybe about 3. All right. So that's my estimate. You could have a different one if you want, but I'm thinking it's about 3. All right. And then my point is at -1/2, -0.5, comma. Let's take a look and see. -2. Yeah, looks like -2 to me. And at that point, because remember, we're our tangent line is trying to duplicate the behavior of the curve at that moment. And so since that has a positive slope, that means that our function is increasing at that moment. All right, and then, so there we go. So the equation of the line then would be y plus 2 equals, I estimated 3. It might be different, but that's what I just said to estimate. So I just did the best I could. So I thought it was about 3, and then it'll be x plus 1/2. And of course, there's other ways you can write that equation of the line, but man, that is the quickest way. So that's where I am going to stop. All right, so then at 1 1/4 is point D, and it looks like we have another 0 slope. All right, so, but this time it's not a minimum, it is a maximum. And so let's get our shape. It's already on line, and let's just draw it straight across there as best we can. I'll try to make it look a little bit better. Oh, okay, now this is getting quicker. Okay, good. So let's have it twice as large, and maybe we'll go red this time. All right, so, okay, so that is a slope of 0. All right, so let's come back over here, click a pin. So we've got a slope of 0, and the point of tangency is happening at 1.25, comma, let's look at the graph and see. Let's look at the graph. Looks like 1. Yeah, 1. I think I might have said that. And at that moment, the behavior of the function is a maximum there for just a moment. It's not a absolute maximum. It's called a relative maximum. It's a moment where the slope is of the tangent line is equal to 0. So we have a maximum at that moment. And then coming back to over here. So then we got y minus 1. So y minus 1 equals 0 times a whole bunch of stuff. Who cares? It's going to be y equals 1. All right. That's the horizontal line. But we'll keep going. So x minus 1.25. Yeah. And that would be perfectly fine. But the easiest way to write this would be y equals 1. All right. Yay. All right. So then one more. At 4. That's all it's asking us to do? Okay, good. So at 4, so that was at 1 1/4. There's 2. There's 3. Here's 4. Okay, so another line. Pretty steep. Let me draw it down this way. And then I'll extend it the other side. All right, so make it a little bit bigger. Make it a different color. We'll go this color this time. And then see if we can make it. That's just going to move it. No, that's doing right. It's doing right. All right. Okay. So that looks pretty good. Okay. And so then, again, we want to estimate the slope here. It's very steep. 1, 2, 3, 4, 5, 6, 7, maybe about 7. Again, hard to tell. We'll just go with it though. All right. So, my derivative estimate is 7. At this point, 4, comma, gotta go back up and look at the graph. That's a 3 in it. 4, 3. Okay, so 4, 3. And once again, it's increasing. It's going uphill. And that makes total sense because that's what our derivative is at that moment. That's the slope of the tangent line. That's the behavior of the curve. All those things are saying the same thing. Oops, increasing. All right. And so then back here, and our equation of our line is going to be super fast. Y minus 3 equals 7. And it might be something else than that, but that's what it looked like to me. 7 and then x minus 4. Okay, so we didn't exactly follow Gene's instructions as far as how to write the equation of the line. But once again, if it's a free response, this is fine. If it's a multiple choice, they may rearrange it a little bit, but you guys don't have trouble with algebra. So, all right, that's it for example 5. This is a pretty lengthy lesson. We've got a bunch more examples coming. All right.